Good day, teachers and your fellow learners. Today we are going to continue with the topic of forces. My name is Tisetso Mohutle. Let us go right into it. Our presentation outline is as follows. We are going to revise what we talked about in lesson 1 and then discuss the field forces in depth, and then also advise learners and teachers on practical investigations of the field forces. Then we go on to discuss balanced and unbalanced forces, and then we'll end the lesson with a force quiz. Okay, let us just revise what we talked about in the first lesson. We defined what is force and also how it is measured. We looked at the effects of force on motion of objects, and then we made a distinction between what are the contact forces and the non-contact forces. And then we explained the examples of the contact forces, which is the friction, the compression and tension forces. And we also explained the non-contact forces, examples being gravitational force, magnetic force, and electrostatic force. Okay, let us look at the field forces. The field forces, one of them is gravitational forces. What is important in this force is just that, remember, it is an attractive force between any two objects that have mass. The most important here is about the objects must have mass, and the distance between the objects determines how strong the gravitational force is. The further you go away, the two objects go away from each other, the gravitational force is going to be very small. Let us look here. This example is not, basically learners don't have to know how to use this equation at this stage, right? But what I can explain here, it says here on the left, gravitational force Fg is equals to the product of the masses of the objects that are attracting one another, and then divided by the distance between the masses. Meaning, if two objects go further apart, we expect that the gravitational force will always become smaller. So the more you move away, if you move away from the earth itself, if it's attracting you with gravity, whenever you move away, the force of gravity becomes smaller. Okay, let us look now. The other field force is magnetic force. What is important about this is that the magnetic force, unlike the gravitational force, it has got attractive and repulsion properties. Okay, so if you have two magnets, you can find that if you put the two north poles together, they will repel, and you put the north and the south, then they will attract. Now, the other thing that is important about magnets is that magnets don't attract anything. They just attract all the materials that have magnetic properties. And then the next thing is electrostatic force. Electrostatic force, just like the magnetic force, it is also attractive and repulsive depending on the charges. We know if it is two positive charges, there will be a repulsion force. If there are two negative charges, it will be a repulsive force. But the positive and the negative, they attract one another. But the amount of force also depends on the distance, just like with the gravitational force. Whenever you bring two charges together, the closer they get to one another, the electrostatic force of attraction or repulsion becomes larger and larger. If you move the charges apart, the further they move away from one another, the force of attraction by electrostatic force, it becomes lesser and lesser. Okay, now colleagues, it's very important that learners and you learners can also understand the field forces. It is very important that you look at conducting these investigations. And they are very simple to conduct because you need only simple materials. For example, if you want to explore the gravitational force using falling objects, you will need a stopwatch, a measuring tape, and then the things that you're going to test the gravity with is the ball. I suggest the tennis ball, the feather, the paper, and the coin, and also an elevated platform like a stoop outside your classrooms. Okay, as you go through that experiment or that in practical investigation, these are the most important things that learners must know. Gravitational force is an attractive force. That's the first thing. Number two, objects fall due to gravitational force. They accelerate. It means something that is falling from up the sky, as the more it approaches the earth, the speed increases. It's very important that you know that. And then if you experiment with all the four things there, you realize that the feather will always take longer to reach the ground from a falling height. So which means that then learners should know that what determines how long it takes for an object to reach the ground. It depends on the air resistance. It means the air can slow down some of the things that we are investigating here. The feather will take longer because of air resistance. In the absence of air resistance, very important, all objects will fall at the same rate, irrespective of the masses. Whether it is 5 kilograms or 5 grams or something, they will fall at the same rate. Okay, and then you should also explore this equation when you do that experiment that says learners can eventually calculate the approximate amount of gravitational acceleration using the height at which they let things fall from the top position to the ground. They can measure that height using a measuring tape, and then they can use a stopwatch to measure the time every object hits the ground, and then they can work out the table to determine which one the times, and then they get the average times, and of the times, if they get a time of every object there, they can be able to calculate gravitational acceleration for each of these objects. Then they will see that most of the time the value that they get will be approximately the same, because the same gravitational acceleration is happening to all the objects that are being tested. Okay, now let's go to the other one, the practical investigations where objects are charged by friction. Learners need simple things as listed there. Okay, it's all about rubbing a ruler with a woolen cloth or a silk cloth, or rubbing a ruler with a woolen cloth, or using the glass rod, and so all those combinations. What is important is learners, they must experience charging objects using the rubbing or friction. Okay, now the results, most of the most important things that they need to know are the ones that the findings that are listed there. They must know that when you rub things together, the electric charges are going to build up on the surfaces of the two objects. Okay, right. Rubbing objects together can transfer electrons. It means by rubbing two objects, electrons will move from one object to the other. The third thing, the charged object induces a charge. It means the other thing, you can charge an object, but when you bring it to an uncharged object will also become charged. So they'll also learn that thing. Okay, the fourth thing, the strength of attraction depends on the material's ability to transfer electrons. For example, rubbing a ruler with a woolen cloth compared to rubbing it with a silk cloth, the force of the charges or the electrons transferred from the woolen cloth may not be the same amount of electrons transferred from the silk cloth. So it means using different cloths, the ruler can be charged differently. Right. The other experiment is about the magnetic attraction. Learners will need a bar magnet and any of the things that are listed here, the iron nails, copper nails, aluminum, plastic bag, and so on. What is important here, learners every time they will try and push the magnet towards these objects, noting the distance between the objects. The one that will get attracted closer to the magnet means it means the magnetic strength was not that strong. But the ones that are attracted by the magnet from a further distance, it means the magnetic strength was very strong. Okay, but what is important here is for learners to identify which materials can be attracted and which ones cannot be attracted. And those that are attracted, then they should label them, and then the others also label them. Then they know which materials are conducting, can be attracted by the magnet. What is important here about the findings of this experiment? A magnet is an object that produces magnetic field. Learners should know that there's something called magnetic field, which is an area around the magnet where the magnetic force will happen. So it means sometimes when learners are pushing objects towards the magnet, they may not be attracted to the magnet until they fall into the area around the magnet, which we call magnetic field. Secondly, only materials that contain iron or other magnetic metals like nickel, cobalt, and so on can be attracted by the magnet, not all the materials. And then the other thing, the pure iron, all materials that have pure iron will have strong magnetic field. I mean, you'll be attracted very fast by the magnetic field of the magnet. All right, colleagues, the last slide is about the balanced and unbalanced forces. Definition: forces are, for balanced forces, we say forces are equal in magnitude, in size. For example, if you look at this diagram, you see there are 3 people pulling the rope to the other side, and then the other are pulling to one side. So, but what is important here, the forces are equal, but the forces are directed in opposite directions. When we get a situation like this, we say forces are unbalanced. If you go to the next picture, you see the forces are still being pulled into opposite directions. The other one is to the right, the other one is to the left. But the only thing you see on the left of this picture, the force is bigger than the other one. When we get a situation like this, we say forces are unbalanced. Now, what do they learn out of this diagram about balance and unbalanced forces? What is important is that when forces are balanced, there will be no motion. It means this rope will go nowhere. When forces are unbalanced, there will be a motion. So unbalanced forces, they actually lead to an increase in motion. Okay, and the last thing, learners, it's a quiz that you can take now to test whether you understood the lesson of today. Thank you very much.